Alright, to answer the other page you gave me, I think it was number 16. You have to understand different formulas now for this one. So for the first part, we're going to be using this formula. A equals P times 1 plus R divided by N, all raised to the N times T. Now, for these formulas, it's like you're just plugging in stuff everywhere. So this is what each part would mean. P means the principal amount, or whatever money you're starting with, whatever they tell you, the big number, like 10,000, whatever. That's what you're starting with. And what you want to do is multiply that by stuff to increase it somehow. And this is the stuff you're increasing it by. So P is just whatever you're starting with, and A is the amount after the years. After everything, A is the number, the left-hand side is whatever your result is going to be. After, like, what it could probably just go up by $1 or something, so this will be your answer plus 1, plus $1. So now R is just your rate. So we use R just once here. So here it's our rate, and just an example, if they gave us 9%, right, of increase over time or something like that, the way we want rate to go into this formula is like this. So we have a 9. You have to move it over 2 decimal places. So that's 1, 2. So right here. So we just fill in a 0, right? So if they said our rate was 34%, that would be 34. So it starts off here, right? Because 34 is a number. So we go 1, 2 decimal places. So we're going to put 0.34 as our R, and if they gave us 9%, we'll put 0.09 as our R. So that's what we put here. We don't put 9. We will put like 0.09. Now N is, we use it twice here. So N represents the number of times compounded, right? So you'll see N. I'll show you something later. And T is just the time, right? Or the amount of years. Compounded. So this is the formula, but really N is all that we're going to be changing. The number of times compounded. So that's basically it. So if we go to our problem, it was let me just put this out to refer. So this is A, and I'll just have it here. So our problem, it said, I think Susan something, I forget, but they said something about $8,500, right? So since that's what we're starting off with, that's simply our P. Now they said we do it over 9 years. So 9 years is simply our T. That's it. That's all we want. Rate, they said 5%. But we don't want it like this because we can't use just 5 in a formula. So like I said, I'm going to take that 5 and move over 2 decimal places. So this is what we're putting into our formula. We're putting in 0.05. And now, so this is basically, we got a lot of our formula. So all we need left is our N. So the first part, they're telling you that we're just shorthand. We're compounding it quarterly. So what does quarterly mean, right? Think of quarter as there's 4 quarters, 1/4 or something. So in a year, what's 1/4 of a year quarterly? It just means that we're going to be using n equals 4. So we're going to be compounding it 4 times, right? Throughout the year. The entire year we're going to do it 4 times. So in this case, just quarterly, our n equals 4. Since throughout the year, 1/4 of the time we're going to compound it, and we're going to compound it the 2nd fourth, then the 3rd fourth, then the final fourth. So quarter, just think of 4 parts, I guess. So n equals 4 in this case. So if we go to our formula, right, we have our P, which is what we're starting off with. We have our R, which is our rate. We have our T, which is our time. And N, we just got it. We just said N equals 4. So here, to answer I, which is what we want A to be our answer, here it's just basically plugging into the formula. One plus the rate, 0.05, divided by the amount of times we're compounding it, n times t, which is 4 times 9 years. So if we plug all of this into our calculator, that's our answer. So I'll let you finish that off. Just remember that 0.5 divided by 4, you add 1, you raise that to the 36, and you multiply by 8,500, and you'll get your A. Now, the next part, they're saying, what if it was compounded monthly? So monthly just means we're using this exact same formula, but our n equals 12. So we're doing the same formula, it's the same interest, same years, but in this case we just switch our 4 for 12. And that's it. You just find the answer to this one. Now finally, this is our last part. What if it was continuously, which is 3? Continuously compounded. Now, in this case, we're using this formula, E, right, E. So P, again, is what we're starting off with. R is the rate, T is the time, and E is just the number we have in our little calculator. So all of that, we're raising E to that, right? So P is what we started off with, multiplied by something that, this will do something, and it will increase it. So it'll just increase it slowly. It could increase it by $2. It could double it or something like that. So it says, how much time would it take for the interest to double? So like we said, A is our final result, and P is what we're starting off with. So if our end result we want to double, then first, let's see, what's 8,500 times 2. What the question is asking is, how much time would it take, using that rate, for A to be double of what you started off with, right? So basically, we have everything. We have our A, we have what we're starting off with. E is just a number we find in our calculator. Our rate is 0.05, so we're multiplying. So they're just asking us for T. So how do we solve this? First, we could take away 8,500 from both sides, or what we mean is just divide both sides by 8,500, and this would be 1, and this would be 1. So you're just left with, to rewrite this, 2 equals e to the 0.05 t. Right? So how do we get t to go down? Well, here's a little trick. When you find that log, natural log of, let's say, 5 to the third, what you can do to the natural log, it's a rule, a property. The exponent that you have, you can bring it down and leave whatever's on the inside, now whatever the base is. So this equals 3, because we brought it down, multiplied by the natural log, and we leave what's on the inside, right? So if this was a 4, then this would just be a 4, right? So whatever our exponent is, we could just bring it down. It doesn't matter if it's, let's say we had 5. It doesn't matter if it's 5x minus 3 or whatever. We bring that entire thing down. And another trick is to know that the natural log of e is just 1. If you plug that into your calculator, natural log of e to the first you can use. Natural log of e is just 1. So we want to take away the e. We want this to happen, right? So this is what we do. If we're going to natural log this side, then we have to natural log this side. So let's find the natural log of both sides. See? And the natural log of this side. So we have e to the 0.05 t. Now let's look at this, what I just said. This is an exponent, right? So by this rule that I said, you can just bring it down. By the properties of this, we can bring this entire thing down to the front and multiply it by the natural log of e. So let's do that. We're saying natural log of 2 equals, I'm going to bring this down to the front. So we just have 0.05 t times the natural log of e. And what did I say this whole part can be? The natural log of e is just 1. So that's gone. 1 times all of this. So we have natural log of 2 is just a number, right? There's no variables here. And this is 0.05 times t. So to find t, we're just going to divide 0.05 by both sides. And we got our answer. So just to rewrite this, the natural log of 2 divided by 0.05 is our answer. And so, yeah. And I think the teacher said nearest cent. So nearest cent means that if you have like $5 and 3, 5, 8, if you have more than, you can't have more than 2 decimal places. If you have a third one, then you just round this part. So this one would just go up by 1 if that's greater than 5. So that's how, by the nearest cent, you just want 2 decimal places. So this is the time for when you have a continuous compounding of your initial number. So you see here we doubled it, and then we just use the natural log to get the t all by itself. And that's it.